Welcome to the Oasis, a Fortnite Island where you can sit back and listen to some music while you relax or talk with your friends. Let me show you how to create an oasis of your own.
First of all, hi, I'm Stefan, I'm an Unreal Authorized instructor, and in this tutorial series I'm going to show you how to create this custom Fortnite experience from start to finish. In this experience, the players can walk around the environment or choose to sit down and relax on one of the benches around the tree. They can listen to a song I've created specifically for this, and the environment will be animated to the music. The players can switch between two versions of the song with a simple user interface. The default version with the main voice and the instrumental version without it. If you don't want to listen to my voice, it's okay. The purpose of this tutorial series is to get to know many different tools within UEFN and for you to be able to create your own Fortnite islands from scratch. This tutorial series is going to be split up into 4 parts. In part 1, we're going to create the environment. In part 2, we're going to tackle visual effects, so particle systems, etc. In part 3, we're going to talk about animations and music visualization. And in part 4, we're going to implement interactivity and create the user interface. These video tutorials are aimed towards intermediate users, so you should have some basic UEFN experience already. In this part, we're going to create the environment. We're going to start by creating the objects we need for that, the floor, the tree, and the benches around that tree, and then creating materials for them to make them look nice and visually pleasing. By the end of this video, you should be able to create your own 3D objects to customize your Fortnite experiences. Implement a flexible material framework for more streamlined controls over surface properties. Optimize your materials for various platforms, and apply procedurally animated effects to your materials. Alright, I'm going to start by creating a new blank level. Inside of this level, I'm first going to delete everything I don't need and then add in the things I want. So I don't need this player start. I also don't need the floor. And now I'm left with just a sky, a player start, and my island settings. I'm going to create this disc-shaped floor now, and I could just use a cylinder for this by going to Place Actors, Shapes, and Cylinder. Place it in the scene. Center it by resetting the location value to 0, 0, 0, and then scaling it up to, let's say, 60 on X and Y. And this is roughly the shape and size of the floor I have in my original level. The only issue is that the standard cylinder shape has not the best resolution, so it doesn't really seem round here at the edges. We won't see it from this angle, but we will see it from here, and you will be able to notice that. So I'd like to create a cylinder that has a bit more resolution. For that, I'm going to make use of the modeling mode. First, I'm going to delete this cylinder. And then I'm going to switch to the modeling mode by going up here in the top toolbar, selection mode, and selecting modeling mode. The shortcut is Shift and 4. This brings up now my modeling toolbar, and here I'm already in the create section where I can create shapes from nothing. I'm going to choose a cylinder, and here I now have the settings for my cylinder. I'm going to select a radius of 3000. And a height of around, let's say, 50. The radial slices is basically the resolution that I want to increase. If I move my cursor in my level now, I see a preview of the shape I'm going to create. Right now it doesn't have a lot of resolution, even less than the cylinder before, and the radial slices is 16, so 16 subdivisions to create this round shape. Let's turn this up to, let's say, 64. And this seems round enough. I can now tell the modeling mode where to save the static mesh asset that is going to be created, and this is done down here under New Asset Path. I'm going to choose my tutorial folder and meshes. Select OK. Now I just need to click once in the level to place the cylinder, and then I can accept these changes and create the cylinder static mesh and the static mesh actor in the level. I'm going to center it again with the position reset, and I'm done with the floor. Now I have a floor that my players can walk on, but it's also a floor that my players can walk off. So to block the players from walking off the floor, I want to create another cylinder, but this time hollow, and use the walls to block the players from walking off the floor. So I'm going to choose a cylinder again in my modeling mode, cylinder. This time I'm going to increase the radius to, let's say, 3050. Doesn't have to be much larger. The radial slices I can set down to 32 or something, because we're not going to see this blocking cylinder. It's just going to be there to block our players. The height I'm going to increase to around 600. And this should be high enough. Let's left click and accept to create the cylinder. I'm going to center this one as well. And now I want to create walls from the cylinder. For this I'm going to switch to the model category and choose polygroup edit. The first operation I'm going to choose is called inset. I want to inset this face to make the wall. Once I move my cursor inside of the viewport, I can see the inset taking effect. Moving my cursor up increases the inset, moving it down decreases it. I just need a thin wall, so this should be fine. I'm going to left click to accept this. Now I have the inner part selected, and the next operation I'm going to use is extruding it inward. So I'm going to click extrude, and now once I move my cursor downwards, it moves this face downwards and create a wall. I'm going to accept these changes, and now I'm going to switch out of the modeling mode. Alright, now I have a wall that blocks my players from walking off the floor. I need to turn it invisible so that my players don't see it. I can do this by selecting the cylinder and in my details panel just typing in the search bar visible and unchecking the checkbox from true to false. Now the cylinder is invisible, but it will still block the player from walking off the floor. With these changes done, I'm going to firstly save my level and also save all of the assets I have created so far. For that, I'm going to open up my content drawer, clicking on Save All. This asks me what I want to save, the two cylinders I have created, the static mesh assets, and also my still untitled level. I'm going to click on Save Selected. And now it asks me where I want to save my level. I'm going to go into my tutorials folder. I've already prepared a maps folder, and inside of there I'm going to call this Oasis Tutorial. Now I want to start creating my tree that will stand at the center of the scene. I want to create a stylized tree built out of simple shapes similar to the ones from Super Mario. I'm going to start by creating the tree trunk out of a simple cylinder shape and then move on to the leaves, and these will be built out of a simple sphere. I'm going to switch back to the modeling mode for this. Modeling, and here under create I will create another cylinder. The radius should be fine with, let's say, 100, and the height, let's say, 750. Radial slices we can leave as is, as we are going to remesh this anyway later on. I'm going to left click in the level and place my new cylinder, click accept to accept these changes. Next I want to make it smaller at the top so that it grows narrower. For that I'm going to once again select the model category, polygroup edit, and select my top part here. Now I can just scale this by using this little scale cube in the center of this gizmo. I'm going to make sure that my scale snap is set to off and then just scale it down a bit. Something like this. I'm going to accept these changes as well. Now I can move on to create branches out of the same cylinder shape by just scaling it down and transforming it around the tree. I'm holding down the left Alt button and moving my object to create a duplicate. And then I'm just going to rotate it and place it around the tree where I want it. I'm making sure that one part of this branch is sticking inside of the tree so that when I merge them together, there will be no gaps. And now it's just a matter of positioning this around the tree a few times to make it seem natural. So I'm going to duplicate this up here and make a smaller branch that sticks upwards. And having the pivot point here at the bottom of my cylinder helps a lot. I'm going to duplicate this bigger one as well, move it a bit up. And let's create another duplicate. And let's say one more. And with that, I'm okay for now. The next step would be to merge all of these shapes into one and then adapt the shape with the sculpt tools. So I'm going to select all of these cylinders and move on to the voxel category and click voxel wrap. This rebuilds the shape from all of these separate objects into one, and it uses voxels for that, which are basically small little cubes in volume. I can select the voxel count, so basically the resolution of that, here in the top. So setting this down to 64, for example, makes the resolution lower of the mesh and also merges them together a bit more. I think 128 looks good for now, and I'm going to accept these changes and create a new static mesh asset from that. Alright, next I want to change the shape up a little bit more to make it look more organic. For that I'm going to make use of the sculpt tools. These can be found under the deform category. I can choose between vertex sculpt, which uses the original geometry data, or dynamic sculpt, which dynamically creates geometry data as needed. I'm going to choose dynamic sculpt, and then I'm going to use the different brushes to adapt my shape as I need. First I'm going to use the sculpt brush and add some detail where needed. Let's first test out the strength by just dragging on my shape, and the strength is far too high. So let's Ctrl Z that, set the strength down to maybe 0.1 and also the size down to 0.1. I just want to create some bark detail here a bit. And now by dragging on my shape, I can basically paint on it. I'm just going to create some irregularities to make it feel more organic. So just adding a few brush strokes here, a few there. And after I'm done, I'm going to smooth this all over so that the individual brush strokes are not as visible. I'm ignoring the top part here because this is going to be covered. After using my sculpt brush, I'm going to switch to the smooth brush. And then I'm going to increase the brush strength and size and smooth this a bit over. Next, I want to add some detail at the bottom to make it seem as if there were some roots in the ground. For that, I'm going to use the grab brush, and I'm going to increase the size a bit so that I can grab a bigger chunk of the tree. Maybe a bit more. And I'm just going to drag a few things down here into the ground, like roots. If something seems too small, I can also use the inflate brush and inflate these parts. Afterwards, I'm going to smooth them over a bit. And once I'm done, I'm going to accept these changes. For the leaves, I'm going to make use of a similar workflow. I'm just going to base it off a sphere and duplicate it around a few times. So still in my modeling mode, I'm going to go to the create section and select a sphere. The radius with 200 seems fine for now. And I'm just going to adjust the pivot location from the base to centered, so that the sphere has the pivot point at its center. I'm also going to toggle off align to normal, so that it just places the sphere where I want it and doesn't rotate it based on the normal of the tree. I'm going to place this sphere here and accept these changes to create a static mesh asset and actor. I can duplicate it around a few times to create a base shape for my leaves. I'm going to start with a bigger sphere in the center and then a few smaller ones based on the branches of my tree trunk. When I see a bigger hole, I just fill it up with another sphere. This is now the general shape, and I'm fine with that, so I'm going to save my level before I'm going to merge these shapes into one. So I'm going to select all of the spheres and go back to voxel wrap and take a look at the result. Let's see how it looks with 64. It merges them together a bit more, but it also makes them less round. But for now that seems fine, so I'm going to accept these changes and create this new static mesh asset. Next I'm going to adapt the shape of my leaves a bit with the sculpting tools. So under deform, I'm going to choose dynamic sculpt once again and use the sculpt brush. I'm going to decrease the strength once again to, let's say, 0.1. and the size as well. Then I'm just going to drag a bit on top of my shape and smooth out these transitions. I'm going to add some detail for some more irregularities, and afterwards I'm going to smooth it all down. Alright, this feels a bit more organic now, and I'm fine with that, so I'm going to accept these changes. Afterwards, don't forget to save. Now I'd like to add some random detail to my shape. For that I'm going to use the displace functionality. This uses noise to displace the mesh. On the top here I can choose the noise type, either a Perlin noise, some sine waves, random noise, or even texture maps are possible. To use texture maps you need UV coordinates. I'm going to use the Perlin noise, and down here in the Perlin noise options I can set my frequencies however I need them. With the displacement intensity I can adjust how far my vertices are pushed. This looks okay for me, so I'm going to accept these changes. Alrighty, the tree looks good now, but it still looks rather grey. Let's change that by creating a material for it. Now we could just build a simple material, throwing some textures in there and be done with it. But I'd like to show you some techniques to build a versatile master material that we can adapt to many purposes by using material instances. Now I'm going to assume that you have some basic material editor experience and know about PBR. If not, there's a great documentation page online. I'm going to link it down below. On this page we have a great overview of physically based materials with screenshots and a lot of explanations. There are also some images that show you what changes, for example, when the roughness value changes. And you can just drag the slider and see what changes on the sphere. Let's start by creating a new material asset. I'm going to go into my content browser, into my mat folder for materials, and right click and create a new material. I'm going to call it m_pbr master and double click to open the material editor. I'm going to navigate to my textures and I'm just going to drag in the base color, normal, and occlusion roughness and metallic map. Now for those of you who don't know, the occlusion roughness metallic texture is an example of a packed texture. This uses the red, green and blue color channels to save grayscale data values. In the red channel the ambient occlusion information is saved. In the green channel, the roughness information is saved, and in the blue channel, the metallic information is saved. Since this tree bark is not metallic, it's just black. To make our master material versatile, we're going to make use of parameters. Parameters are variables that we can change on a material instance basis. The first thing I want to be able to change is these textures, because I don't always want a tree bark texture on my material. So I can select all of these textures at once and right click on them and convert them to a parameter. Now I can name them base color, normal, and occlusion roughness metallic, short ORM. I also want to implement controls over how these textures are mapped to 3D surfaces. Per default, the textures are going to be mapped using UV coordinates. I also want to implement triplanar mapping, which maps the textures based on the surface position. Let's start by implementing the UV coordinates and some controls for that. I'm going to move to the right for that to get some space and add my texture coordinate node. For that I can just hold down the U key on my keyboard and left click, which creates this node for me. If I put this into my UV inputs and preview this node, this is just the default behavior. But I want to have control over how big or small this texture is on my surface. For that I'm going to implement a tiling functionality. Let's take a look at the UV coordinates by themselves. The texture coordinates are a two-dimensional gradient, here in red and green, going from 0 to 1 in both directions. If I now increase or decrease these values, the textures that are mapped on top of these gradients are going to appear bigger or smaller. And the easiest way to do this is to multiply this by some value before putting it into the UV input. So I'm going to hold down M and left click for multiply and connect this into A and the result into my UV input. I'm going to start previewing the base color again, and if I increase this value now, let's say to 2, the texture appears smaller. If I decrease it to say 0.5, the texture appears bigger. To be able to change this, I want to create a parameter for this. Parameters that control one-dimensional values in Unreal are called scalar parameters. The shortcut to create one is holding down S for scalar and left-clicking. I'm going to call this UV tile. Each parameter has a default value that I can set here. I'm going to set the default value to 1 and connect this to B. Next, I want to be able to control the rotation of the texture. For that, we have a handy node called the custom rotator. Right-click, custom rotator, and I'm going to put in the multiply result into the UV's input. The rotated values output I'm going to put into the UV's input of the texture. This node has two inputs, the rotation center and the rotation angle. Rotation center is a vector 2, so in 2 dimensions, but we are going to leave this as is because I always want to rotate around the center of the texture. The default value here is 0.5 in both directions. The rotation angle goes from 0 to 1, is also a scalar value, but I want to be able to input a value between 0 and 360, so not radians but degrees, to make it easier for my brain. First, I'm going to create a parameter for my rotation. So S, left click, UV rotation, and the default value is going to be 0. If I put this straight into the rotation angle, it's just going to accept values between 0 and 1. To be able to input values between 0 and 360, but still have it come out as values between 0 and 1, I'm just going to divide this by 360 and put in the result into the rotation angle. So if I now put in 0, it still remains 0. If I put in 360, which is 1 full rotation, it puts out 1. Let's test this out. Let's put in 45. And my texture is now rotated 45 degrees. To minimize visual clutter with all of these node connections, and also to keep myself organized, I'm going to make use of comments and named reroute nodes. So instead of putting the output here directly into my UV's input, I'm going to create a so-called named reroute node, named reroute declaration node, and I'm going to call it UVs. Once I have created a named reroute node, I can access it from anywhere within my material graph. And this just gives me all of the values that I feed into here. Now I can duplicate this for all of my textures. And this makes my material graph much cleaner. With comments, I can now keep myself even more organized. To create a comment, I'm going to drag select all of these nodes and press the C key for comment on my keyboard. Now I can name this comment box and I'm going to name it UV controls. Now I'm going to build the triplanar mapping method. I'm going to move up here and drag in my textures again. For the triplanar mapping, I'm going to use a node called world aligned texture. So I'm going to right click, type in world aligned, and there's a world aligned normal and world aligned texture. I'm going to use the world aligned texture for the base color and the occlusion roughness metallic map, and the world aligned normal for the normal map. These nodes accept texture object inputs instead of texture samples, but I can just convert them. So I'm going to select all of them, right click, and convert to texture object. Now I can put them into the nodes. To be able to change these textures in a material instance, I'm going to convert them to parameters as well. So let's right click, convert to parameter. I'm going to call them the same names as the textures below. Occlusion roughness metallic, normal, and base color. Instead of a UV tiling that defines the size, I have a texture size input here. This is a vector 3 because it's 3-dimensional. I'm just going to use one value for all 3 axes. So I'm going to create another scalar parameter, and I'm going to call this world aligned, WA, texture size. I'm going to set a default value to 100, and this is centimeters or Unreal units. I'm going to connect this node to all of these 3 nodes here, and that's good. We have one issue with the occlusion roughness metallic texture. Because it's a packed texture, it needs some special attention. The thing we need to change here is to set this export float 4 to true. It's a Boolean input, and if it's set to false, which it's set per default, it will only export the color combined. But that's easily changed. I can just drag out of this input and type in static bool, and set this value to true. To be able to choose whether to use the world align textures or the UV map textures, I'm going to implement a switch parameter. So I'm going to right click anywhere and type in switch parameter. And I'm going to call this use world aligned textures. Now I could duplicate this switch for base color, normal, occlusion, roughness and metallic each time, but we're trying to work smart, not hard. So instead we're going to make use of material attributes, which gives me only one input and output that I need. I'm going to select the main material output node, and in my details panel, I can choose use material attributes. This collapses this down to one input, which accepts a make material attributes output. And here I can input my base color, metallic, roughness, whatever. All right? So now I can build my materials. Down here, the UVs. So the base color goes into base color, the normal goes into normal, ambient occlusion into ambient occlusion, roughness into roughness, and metallic into metallic. With that done, I can create a named reroute node to keep organized and call this UV textures. Now I'm going to create a comment around that and call that UV textures. Going to move this down here. And let's create a make material attributes node for the world aligned textures as well. Right click, make material attributes, and connect the nodes. Here the XYZ texture is the output I want. So base color, normal. And here I need to break this down into the R, G, and B channels, and that's why we added the static bool here. So break out float 3 components, R, G, and B, red, green, and blue. And now I can connect the red channel to the ambient occlusion again, green to roughness, and blue to metallic. I'm going to create a named reroute node for this one as well. Named reroute, call this world aligned textures. And maybe spell this well. And create a comment for that as well. With these two reroute nodes, I can now use them, world aligned textures, in the switch, and UV textures in the switch. The result I can now put into my material attributes into the master node. And if I stop previewing this, I see my material applied to my mesh. But we're not done yet. I want some more controls. For example, I want to be able to change the color of the base color, so tint it. I want to be able to change the contrast of the base color. I want to be able to control how flat or strong the normal map is, and also some controls over roughness, metallic, and ambient occlusion. I could implement this on both sides here, for the world aligned textures and for the UV textures as well. But once again, double the work. So I'm going to implement this here, between my switch and my main output node. So I'm going to make some room here, and first I need to be able to access these channels again individually. For that I can use the get material attributes node. And this just seems like one simple node, but here in the details panel I can add in the channels that I need. So I'm clicking plus 5 times. And I need the base color, metallic. I don't need specular, I want roughness, normal, and ambient occlusion. Now this gives me the outputs that I set here, and I can adapt them as I need. To then override these values, I'm going to use a set material attributes node. Once again, I need to input the channels that I want to change here, so I'm going to click plus 5 times again. Base color, metallic, roughness, normal, and ambient occlusion. And this output I will put into the main output node. Let's start with the base color adjustments. I'm going to add the contrast controls first and then some tint controls. So dragging out of base color, I'm going to type in contrast and use the cheap contrast RGB for colors. The contrast value is one singular scalar value from 0 to 1 or even above if you need to. I'm going to create a scalar parameter, S and left click, and call this base color contrast. I'm leaving the default at 0 and putting this in. The result I'm going to multiply with another color, and this is going to tint my base color. To be able to change this color that I want to tint this with, I'm going to create a vector parameter. Holding down a V for vector and left clicking creates a vector parameter, which can be a color, and I'm going to call this color tint. The combined output I'm going to put into the multiply input, and the multiply output is going into the base color. I need to change the default color tint value from black to white, otherwise it's going to appear black. For some instances, I might want to use set values instead of the texture data for ambient occlusion, roughness and metallic. That's what I'm going to implement next. I'm going to create a switch parameter for that again. So right click, switch parameter, and I'm going to call this use metallic texture. And the metallic value goes into true, and into false I'm going to just set a scalar parameter. S left click and call this metallic. I'm going to set the default value to true and put this into metallic. The same I'm going to do for roughness and ambient occlusion as well. So I'm going to duplicate both of these nodes. Renaming them creates new parameters. So selecting both of them and hitting Ctrl D creates a duplicate. With F2 I can rename this to use roughness texture. And instead of metallic I'm going to call this roughness. The default value I'm going to set to 0.5 and connect this to roughness and the true to roughness. Once again, this time for ambient occlusion, use ambient occlusion texture, the true to ambient occlusion, the false to AO, and the default value is going to be 1. Result into ambient occlusion. Lastly, I want to control how strong my normal map is. For that, I'm going to use the flatten normal node. So I'm going to drag out of the normal output, type in flatten, and the flatness is another scalar parameter, normal flatness, default at 0, and the result gets piped into the normal input. With all of that done, I can create another comment around this and call this texture controls. Let's save these changes. Let me create a material instance to show you some ways on how to optimize this further. So in my content drawer, I'm going to right click on my material asset and click on create material instance. I'm going to call this mi_test for now and double click to open the material instance editor. Here I can now see a preview mesh with the material applied to it and also all of my parameters that I have set here. One thing I'd like to optimize is these parameter group names. These are normally named based on the parameter type, like scalar parameters, static switch parameters, texture parameters, and so on. But if I want to group them differently, I have the control for that. So back in my material, I can select one parameter, like the UV tile and UV rotation, for example. And in the details panel, there's a group setting. If there are no groups in the material, I can just create one by typing something in. I'm going to call this UV controls. The world-aligned texture size I'm going to add to a group for the world-aligned controls. The texture parameters are going to go into a group called textures. All of my texture controls, the base color tint, contrast, metallic roughness, occlusion, and normal, is going to go into a group called texture controls. I'm going to create it by selecting one of the parameters and typing in texture controls. I can select multiple parameters of the same type and assign them to the same group at once. Don't forget the switches here. And that's done. The use world-aligned texture switch is going to get its own group called mapping. Once I save my changes and go back to my material instance, it should show me all of my parameters neatly structured. So here in my material instance editor, I can see mapping, texture controls, the textures, and the UV controls. Notice that based on the switch setting here for use world-aligned textures, it only shows me the controls that are relevant for this switch setting. So if I switch this from use world-aligned textures from false to true, it will change this from the UV controls to the world align controls. Before I can apply the material to my tree trunk, I need to add UVs. For that, I'm going to switch back to my modeling mode, and there is a section called UVs. Here I can either make use of automatic UV mapping or UV projection, or I can create my own UV seams and create my custom UV set. This is what I'm going to choose for my tree trunk. I'm going to hide my tree leaves mesh for now and just focus on the tree trunk. I'm also going to hide my floor using the H key. If I select my tree trunk mesh now and go to Edit UV Seams, this allows me to draw UV seams on top of my mesh, and these are going to be the seams on which this mesh is going to be cut open and laid flat on the UV space. Since this trunk is mostly a cylinder shape, I'm going to create a cut down here and also a cut on the bottom and the top. Then I'm going to separate the tree branches and also cut them. I can just left click and drag, and this green line shows me where the seam is going to sit. Something like this looks fine. And now I can create a seam around the bottom of the tree. Most of this is going to be hidden by the floor anyways. But if I don't set the seam, the UVs will be a bit weird. I'm going to move on to the top of the tree now and make sure that my UV seam reaches the top and then cut around this edge. Once again, this part is going to be hidden, but I just want to make sure. With that done, I can accept these changes and do a first test unwrap. So selecting UV unwrap shows me a preview of how this mesh will look. And here at the bottom, it already looks okay, let's say. And once I will have separated these tree branches, the top might look better as well. So let's further add UV seams here. Once all of my UV seams are set, I can click accept to accept these changes. Now I still need to UV unwrap this. So let's select the tree again, UV unwrap, and this looks okay. At least it's rather even. I'm going to accept these changes. And now I can create my material instance for this tree trunk and apply it to the tree. So I'm going to just rename my test material instance to mi tree trunk and just drag and drop it onto the tree. It looks okay, but I have to adapt it a bit. First, I'm going to tile this a bit more, let's say 2 times. So in my material instance, I'm going to set UV tile to 2, and this looks better from the scale. But there are also some other issues. For example, this tree branch, the bark runs in the correct direction, but here it runs incorrectly. And here as well. This is why we used custom UV coordinates, because now I can change this based on the UV island. Having my tree selected, I can go to Transform UVs, and now I can select the individual UV islands and rotate them. And this is a really great tool. This looks fine. This is better. Okay, accept the changes. And now everywhere the bark runs in the direction that you would expect it to run. Maybe let's increase the tile size to 3. And I'm happy with that for now. For the leaves of the tree, I want to make use of the triplanar mapping that I've implemented into the material. So I'm going to create another material instance. Right click, create material instance, call this mi_tree leaves. And I'm going to already apply it to my leaves here. Since this mesh has also no UVs, this might look a bit weird, but that's okay. We're going to change this. I'm going to double click to open the material instance and first change the textures. I have a base color and a normal map for that. I'm not going to change the occlusion roughness metallic texture because I'm not going to use the texture data. For that, I'm going to use the switches that I've prepared for that. So let's switch them all off. And I think the default values are fine for now. I also want to change use world align textures to true. And then I might have to play with the size a bit. Let's save that. And let's see how it looks. It's okay for me for now. Maybe I want to make it a bit darker. So for that I have the color tint option here. I'm going to add a bit of green and make it darker. Something like that. Alright, that looks okay for me. Next I'm going to create this bench that I want to arrange around the tree for the players to have something to sit down on and relax. I'm going to start by creating one wooden plank, which will be used to construct the whole bench. I'm going to switch back to the modeling mode. Here under create, I'm going to create a box this time. The width will be 200, the depth will be 10, and the height will be 5. So it looks like a very simple wooden plank. I'm going to set the pivot location centered and just place it somewhere on the floor. I'm going to click accept to accept these changes. Now I first want to create a material for my wooden plank and adjust the UVs as needed before duplicating it and using it as the base for the construction of the bench. For that I'm going to create a new material instance of my master material, call that mi wooden planks, and double click to open it up. For the textures I'm going to change the base color and the normal texture. So I'm going to check these checkboxes, and inside of UEFN, inside of the Fortnite folder, I have a lot of textures that come with UEFN. I can search for all textures within the folder by using the filters in the content drawer, and if I filter for textures, it gives me all of these textures that are available to me. Here the first wooden planks look fine to me, so I'm going to use this one as the base color and this one for my normal map. Let's save this and apply it to my plank. Now I can already see some issues, like here on the top and also on the bottom. The wood does not run in the correct direction. So similar to what we did with the tree, I'm going to transform these UV islands to make them rotate in the right direction. So switch back to the modeling mode. In the UV section, transform UVs. I can select this UV island and just type in 90 degrees here and do the same for the bottom. I'm going to accept these changes, and with that the wooden plank is prepared. Of course I need multiple planks to construct my bench. I could just use duplication, but I also want to show you another tool that we can use for that. Under Xform and Pattern, I can duplicate my selected mesh and arrange it in certain patterns. For the pattern shape, I can select line, grid, or circle. I'm going to choose line, and under linear pattern, I can choose the spacing mode, count, and extent. I think I need 4 planks for that, and changing the extent lets me adjust how far apart these are spaced. Let's adjust the view to see if that works. Maybe 35 or something like that. Alright, I like that. I'm going to accept these changes. Now it might seem odd because there's another plank flickering with the Z fighting, but that's the original plank. It has created a new object for me. So the original plank I can get rid of. So I'm just going to move this to the side. And then I can delete it. And now you can see we just have these 4 planks together. I can now duplicate this to create the backrest. So I'm going to move it up. Going to use my rotation snapping to rotate it. And then I'm going to rotate it like so, maybe 70 degrees. And set it at the back of the bench. Let's rotate it up a bit more. Something like that. For the rest of the bench, I'm just going to use the single plank again. So I'm going to get it from my content drawer and adjust it to create the feet. Let's rotate this by 90 degrees and create one across. I can now duplicate these 3 objects to the other side, like so. And I'm going to create another brace in the center. Doesn't have to be perfect for now. And now I'm going to duplicate all of these 3 braces in the bottom and move them over to the backrest. I'm going to also rotate them by 80 degrees and place them at the back. It doesn't have to be perfect, so that's fine for now. For all of these new objects, I'm going to also apply the material. And after that, I'm going to merge them all together into one object. For that, I'm just going to use the merge tool under X-form. This looks fine to me, and now I have one mesh for my bench. To arrange multiple of these benches around my tree, I'm going to once again make use of the pattern tool. So here under X-form, pattern, I'm going to create a circle this time, circle, and I'm going to first move this closer to the tree, adjust the radius and the count. Something like this looks good. Let's rotate them around by 180 degrees under the start rotation. The radius, I need to make sure that nothing clips into each other. Let's maybe say 6 benches, then we can put them closer together. This looks good to me now, so I'm going to accept these changes. And with that, we have a circle of benches around the tree. Now let's move on to the floor material. For that, I want to make it look like there is some rockier surface underneath the smooth shining waves. For that, I want to make use of the clear coat shading model. This gives me the option to add a secondary normal information, which seems to lie underneath a clear coat finish. On the documentation page, we can see examples of that, as well as more information on how to achieve that. Let's start by creating a new material asset for our floor. I'm going to right-click in my content drawer, create a material and call that M-Floor Clear Coat. Double-click to open this up. First, I want to change the shading model from default lit to clear coat. This gives me now this clear coat input and this clear coat roughness input. Let's first implement a normal texture that is supposed to lay underneath the surface. I'm going to make use of the Fortnite textures again and just select one that looks good. Maybe this one. If I connect this directly to the normal output, it makes it look like the surface itself has bumps. But I want to make it seem like the surface is smooth, but underneath the surface there are these irregularities. So I'm going to disconnect this, and instead I'm going to connect this to the clear coat custom normal output. Once I do this, I see the normal information again, but it looks like it is inside of a glass sphere. I'm going to add some UV manipulation controls here. So similar to before, I'm going to add a multiply and tile normal. Set this to 2 maybe by default and connect this here. For the base color, let's make this a bit darker and set the roughness down to maybe 0.2. I'm going to create a comment and save this material for now. Once I apply this material to my floor, we should see this taking effect. So now I have my clear coat finish with the normal underneath. It's scaled a bit big, but that's okay. And this looks good. But this only works on higher end PCs and consoles. It will not work, for example, on a Switch, like this one. Let me show you. We have a similar visual effect on this one. We need to fake it. First, we need to be able to tell if we are on a mobile device like the Nintendo Switch, or if we are on desktop or console. And of course, there's a node for that. There are multiple nodes that could be used for that purpose. I'm going to use the shader platform info switch. I'm going to right-click in my material editor and type in shader platform info switch. This node gives me the option to differentiate between different platforms and use different inputs based on the platforms. Selecting this node and going over to the details panel allows me to add a filter. I'm going to expand this and choose the input name is mobile. Under property condition, I set this to property must be true. Now I have 2 inputs on my node. One is mobile and one is not mobile. If it is mobile, this will be piped through. If it is not on the mobile platform, this will be piped through. Now what do I want to change? I want to set it up so that when we are on the mobile platform, I'm not going to use the clear coat shading model, but the normal default lit. And when we are on PC or console, I want to use the clear coat shading model. For that, I have to set up a change in my material itself. So I'm going to select my output node, and under shading model, I'm not going to select clear coat, but from material expression. This allows me to change the shading model with material nodes. Now I'm going to create a shading model node, and this allows me to set the shading model. So one is default lit, and the other one is going to be clear coat. So if we are on mobile, we're going to use default lit, and if we are not on mobile, we're going to use the clear coat option. And this I can pipe into the shading model material input here. To still have some resemblance to the original effect on mobile, I'm going to use the blue channel from the normal map and pipe it into the ambient occlusion. So I'm going to duplicate this switch, and I'm going to create a named reroute node for this one here, and call this normal blue channel, normal B. I'm going to put this into isMobile, and if we are not on mobile, we're just using the default 1 for ambient occlusion, and this into ambient occlusion. I could use the material attributes again and use only one switch, but it's fine for now. I'm going to save these changes. Let's test it out again. As you can see, it now works more or less, so I'm going to put this back for now. Next, I want to create this animated waves effect. For that, I need to adjust the UVs of my cylinder to make sure that the effect works as intended. I'm going to select my cylinder here and go into the modeling mode and in the UV section. I'm going to use project UVs and just use the plane. Once I accept this and open up the static mesh editor, it shows me in the UV channel that this circle is now filling up the whole UV space, and that's what I want. I'm going to save these changes. For the waves effect, I'm going to make use of a radial gradient and separate this gradient into individual lines using the sine function. Let's start with the gradient. I'm going to right click and create a radial gradient exponential. If I preview this on my plane here, this just gives me a gradient from the center to the outer edges in a circle from white to black, from 1 to 0. If I now add a sine function after that and preview that, it gives me a ring, and depending on the period of the sine, it gives me more or less rings. Let's say 0.05. That gives me a lot of rings, and that's fine for now. The issue with the sine function, if we remember back to math class, is that the sine wave goes up and down above 0 and also below 0. We don't want any values below 0, so we're going to saturate this result, which basically clamps the values between 0 and 1. Visually, there's not much change because black is the blackest black that we can show here, and values below 0 will not be shown more black than black already is. Now to animate those waves. For that we need a reference to time, and when time is counting up, it will basically move the waves outwards. So I'm going to add a time node, and before putting in the radial gradient into my sine, I'm going to add time to this. Holding down A and left clicking creates the add node. Before putting time into the add, I'm going to multiply it by a scalar parameter to be able to change the speed. Let's say 0.1 per default to not make it move too fast. Unfortunately, the preview is not always in real time, but once I move it, you should see it move. Alright, and that's the basics of the effect. Now I want to adjust the effect a bit. First, I don't want to have the same distance between all of these circles, so I'm going to adjust that. And also I want to distort these circles a bit so they don't seem so perfect. So let's start. I'm going to duplicate my sine node and connect it to the add again. Now I'm going to choose another period, let's say 0.003, and then I'm going to combine these two with a min node, which uses the minimum value of both of these. If I connect this one now to saturate, we can see some irregularities. For the distortion, I'm going to multiply a noise onto my texture coordinates to basically distort the UVs before applying them to my gradient. Once they are distorted, they will also distort these circles. There's a great noise texture that we can use that already comes with UEFN. Inside of the Epic folder, I can just search for Perlin, and there's a Perlin noise texture. I'm going to import this here. Then I'm going to create a texture coordinate node and multiply this texture with one of the channels of the Perlin noise. If I preview my normal UV coordinates, it looks like this. If I preview the multiply here, it looks like this. So we already have some distortion. I maybe don't want the full distortion though, so I'm going to add a control to control how much distortion there is. For that, I'm going to use a lerp, linear interpolate. I'm going to hold down L, left click, and I'm going to connect the multiply to B and the normal UV coordinates to A. By adjusting the alpha value, I can now blend between A and B. So I'm going to create a parameter for that and call that distort UVs. Let's set this to 0.1, so not as strong, and connect this to the UV input of my radial gradient exponential. If I preview my saturate again, we should see that my circles are now distorted. To have some more detail in this distortion, I'm going to use a duplicate of the same texture, but tile it differently, and I'm also going to animate these textures that are distorting my UVs. So let's do that. First, I'm going to duplicate the texture, and I'm going to create another texture coordinate node and add a multiply. The first multiply will be my main multiplier, my main tiling size for the noise, and the second multiplier is just going to double this multiplication for the bottom texture. I'm going to call this parameter tile distort UVs, and let's say a default value of 2. And this multiply is going to go into UV input here. But before even that, I'm going to animate these textures. For that, I'm going to use a so-called panel node, which moves the textures in X and Y. I can hold down P and left click and create a panel node. I will connect the coordinate input to my UVs, and inside of speed here, I can now input the speed in X and Y. I will put down 0.015 and minus 0.02 for the first one. Feel free to play around with these values. For the bottom one, I'm going to adjust these values 0.025 and 0.04. Now I'm just going to multiply these results and pipe this into the multiply here. Now we can see much more detail inside of my distortion. Let's make sure we clean up after ourselves. So I'm going to create a comment for all of these nodes and call this animated waves. I'm also going to create a named reroute node here at the end, animated waves. Alright, next I want to color these waves and apply them to my material. And to not use any random colors, I'm going to make use of a color scheme. For that, I'm going to use coolers. You can use any website, there are multiple portals doing similar things. And I'm going to explore trending palettes. In here I can find multiple color palettes. I think I chose this one here. I can open it in the generator and take a look at all of these colors. And I can also copy these color codes and then paste them into the Unreal editor. Since I might reuse this color scheme later on in the project, I'm going to save this in my color picker. First, let's create one color. Let's hold down the number 3 and left click. And in here, I can now paste in my hex code that I copied. So here's one of the colors. I'm going to copy over the others as well. Alright, now I have the colors inside of my material editor. To save them, to be able to reuse them later, I'm going to open up the color picker again, and I can just drag and drop this preview on the top here. And now it's available to me later on. I'm going to click OK, and I'm going to do this for the other colors as well. Once I have done this, I have access to these colors from anywhere within the editor. I could also save multiple color schemes by creating a new color scheme and adding colors to that. I want to apply these colors to my waves now, but I also want to make sure that these colors also move outwards. For that, I'm going to need additional controls. First, I'm going to create a named reroute node after my radial gradient. So that I can use it up there. Once again, I'm going to use time and multiply it with speed. I'm going to multiply the speed again by 0.25 to just have a different speed, but still have one parameter that controls the overall speed. Now I'm going to add this once again to the radial gradient, but I'm only going to use the fractional values. So every value behind the comma, and use this as an alpha for another lerp. But this time I don't only want to lerp between 2 values, but 4. For that, there's a lerp multiple float 3. This allows me to lerp between 4 different values with 1 alpha value. So let's connect this one and connect all of these colors. 1, 2, 3, and 4. The lerp 4 inputs is now the output I need. If I only were to input 3 lerps, or 3 inputs in the lerp, I could also use the top output here. I'm going to create a named reroute node for that as well. Wave colors. And let's create a comment for that as well. Now I need to restrict these colors to only happen when the waves are there. So I'm going to multiply them by my animated waves. Because right now it's only circles going outwards. So I'm going to multiply them by my animated waves or animated oasis. So maybe let's fix that. Right. With that done, we now have the colors only happening where the waves are, but they are also blinking outside of there. This should be fine with our cylinder shape ending there anyways, but just to make sure, I'm going to create another radial gradient and I'm going to increase the density here, because right now it starts at 1 and goes down to 0. So if we were to multiply this one here, it only shows me a rather small part of my waves here. If I increase the density to, let's say, 10, it shows me more of my waves happening. And now I'm going to add another named reroute node and call this wave colors masked. And this I can now use to apply to my material. So I'm going to go down to my material output node, use my wave colors masked, and maybe multiply it by a parameter boost, let's say 10. And I'm going to apply it to the emissive output to make these waves glow. All right, once I save this, let's take a look in the level. So there we are. It's still a bit rough and the distortion is too much. So let's create a material instance and adjust some parameters. So right click, create material instance, mi floor, double click to open, and apply this one here instead of the original material. Under distort UVs, let's say 0.05, that's better. Maybe even lower, 0.02, and that seems fine for me. Let's adjust also the tiling of the normal texture, so tile normal, let's say 8, and this looks better, I would say. Alright, that's good for now. I also want these waves to happen on the tree, so they start on the tree trunk, go downwards and then outwards towards the edge of the floor. So I'm going to implement the effect similarly in my tree trunk material. Back in my PBR master material, I'm first going to copy over all of the nodes from my floor material that I need for the waves effect. Of course, I also could create a material function for this to make it even more modular, but this would go beyond the scope of this tutorial. If you're interested in learning about creating material functions, feel free to leave a comment down below. Let's start by copying over everything about the waves from my floor material. I'm going to paste it down here. Instead of basing this effect on the radial gradient, I want to base it on a gradient that goes from the top of the tree to the bottom. For that I can make use of the bounding box based UV. This node gives me 3 gradients, X, Y, and Z, here in R, G, and B. If I preview the blue gradient and maybe take a look at the cylinder, it shows me a gradient from top to bottom. Now I'm going to implement this here where I previously implemented the texture coordinates. So instead of the texture coordinates, I'm just going to connect this to B. By the way, if you want to reconnect existing node connections, you can hold down the Control key, left click and drag, and then you can reconnect them without losing the connections. Now instead of the gradient, I'm just going to connect this directly to the add of the time, and the animated waves, let's start previewing this, should now go downwards. Let's adjust the distort UVs to, let's say, 0.02. Now it's not as strong. So that's a good base for the effect. Instead of this now invalid named reroute node, where I previously had the radial gradient, I'm going to create a new named reroute node and call this gradient and connect it here and use this one on the top here. With this connected and start previewing this node, we should have the colors as before. But now they're moving down. Next we need to mask this again, but instead of masking this with the radial gradient again, I'm going to mask this with a gradient here. I don't want the gradient to go the whole way, so I'm going to use a smooth step for that. First I'm going to invert this gradient using the 1 minus node, and then add a smooth step, putting this into the value and setting the values to 0.4 and 0.8. This changes the gradient from this to this. So it does not really start at the top or end at the top, but rather more towards the center. Feel free to play around with these values. I'm going to add some more space here and create a named reroute node. Gradient mask. And this I'm going to use here up top. If I preview this now, we should see that it starts here towards the center and then goes down. To now add this to my material, I'm going to use another switch parameter. Before the end here, I'm going to add another value that I want to change in my set material attributes, which is the emissive color. So let's get the emissive color here. And I'm going to add the named reroute node for the wave colors masked. Let's make some more room here. Once again, I'm going to multiply them by a boost parameter. Let's say once again, 10. And before piping this into the emissive color, I'm going to add another switch parameter and call this use animated waves. Making this up on the go here. For true, I'm going to set this into true. And for false, I'm just going to put in a value of 0. The default value will be false, and I'm only going to activate it for my tree trunk. The result of this switch I will put into emissive color, and I'm going to make sure that my switch and my boost is in the same category as the other controls here. So switch, set this to texture controls, and boost also to texture controls. Let's save this, and now let's take a look at the material instance. In my material instance, I should now find the use animated waves parameter. I'm going to check it on and set it to true. In the preview, I can already see the effect, and if I save this and go into my level, I can see that now the waves run down the tree trunk and seem to run from the tree trunk towards the edge of the floor. If you want to make your oasis look like it's floating in the sky, you're done. But I want to make my oasis look like it's floating in space. For that, I'm going to make use of the barrier device. So in my content drawer, I'm going to go into the Fortnite folder, devices, and gameplay, and use the barrier device here. I'm going to place it and center it in my scene. Normally it's used to block players from going somewhere, so a blocking volume, but I'm just going to use it as a hollow box and use the material that comes with it. I'm going to scale it up here in my details panel using the barrier depth, width, and height. Let's say 45, 45, and let's say 10, and let's move it down a bit. Under advanced, I'm going to change the zone shape from box to hollow box. Now I'm inside of the box and I can look at the box from the inside. On the top here, under barrier material, I'm going to change this to M barrier bounce portal. And this gives me the look of space. So now it looks like my oasis is floating through space. Alright, let's take a quick recap. We utilized the modeling mode to create our own 3D objects for our scene. We have made use of UV and triplanar mapping as well as material parameters to create a really flexible master material that we can use in many different instances. We have optimized our materials for different platforms by implementing a switch to ensure the best possible visual quality as well as consistency. We have created a procedurally animated wave effect in our materials by using the sine function and some UV distortion to make the scene feel more alive. Once again, you can find a link to the textures I prepared for this tutorial down in the video description. There you can also find links to the documentation pages I featured. Feel free to take a look there and dive deeper. Leave any questions you might have in the comments down below. And maybe even consider subscribing. You might also want to come back for the next video in this tutorial series, where we'll talk more about the visual effects. Alright, that's it for now. Thanks for watching and maybe see you in the next one.